In 2018, the game Candy Crush made an estimated $4 million from in-app purchases and microtransactions per day, and like most of the top-grossing mobile apps, they sell useless digital products to casual gamers. In today's video, you'll learn how to implement consumable in-app purchases in Flutter, allowing you to sell your own digital products on iOS or Android via microtransactions.
Not just doing this for money. We're doing it for a shitload of money.
If you're new here, like and subscribe, and you can find the source code on Fireship.io. And congrats to Andre Hava, you won the t-shirt from last week's Flutter video. Let's start by talking about how in-app purchases work from a high level and how to use them successfully in your app. The first thing you should know is that there are three main types of in-app purchases. Consumables are products that are depleted that can be purchased multiple times, like coins in a game. Consumables are what we're focused on in this video, and we'll build a feature that allows the user to buy some gems, consume them, and then buy some more. The second type is a non-consumable, which is something the user purchases once, like an upgrade, and then should never have to purchase it again in the future. And the third type is a subscription, which gives the user access to the purchase for a limited amount of time. Now, these concepts apply to both iOS and Android, but there are some subtle yet important differences that we'll look at when we get into the code in a few minutes. And another thing you should know about in-app purchases is that they're almost always required if you're selling digital content. That means APIs like Stripe and PayPal are out of the question. But luckily, Flutter just recently released an officially supported plugin for in-app purchases that provides a unified interface across iOS and Android. That's what we'll be using in this video, but it is currently in beta, so things may change in the future. Now, when it comes to making millions of dollars per day, you need to build an app that's both highly addictive and that targets a wide audience.
I wasted everyone's money, I wasted everyone's everything, and I feel bad. You don't think I feel bad?
You should design your interface around dopamine hits and compulsion loops. In other words, reward the user on a regular basis, but always keep them chasing the dragon.
Dad, get off our Xbox!
Hang on, I almost caught the dragon.
You almost got me.
No! No, I said! I am your father! Put it back on!
Mom, you get Dad out of here!
So now that you know how to design your app, let's go ahead and get into the technical details. The first thing we'll take care of is the initial setup for both iOS and Android. For iOS, you'll need to have an Apple developer account, and I'm making the assumption that you have a release of your iOS app on App Store Connect. It doesn't need to be on the public App Store, just App Store Connect for use with things like Test Flight. There are a lot of small but easy steps involved with that are beyond the scope of this video, but the Flutter documentation has a detailed guide for preparing an iOS release, and I also have a video that covers it in my full Flutter course. In App Store Connect, we'll go to the Features tab, add a new in-app purchase, making sure that it's a consumable type. Then we'll give it a name and a product ID, and we want to keep a note of this product ID because we want that to be the same on the Google Play Store. And everything else is just the pricing and display details for your actual product. So now that we have our product, we'll go into Xcode and enable the in-app purchases capability. Select the build target, go to the Capabilities tab, and then flip the in-app purchases switch to on. So that takes care of the Apple App Store. Now let's switch gears to Android and the Google Play Store. At this point, I'm assuming that you have a Google Play developer account, and you'll also need to go through the steps to create a signed release that can be uploaded to Google Play. And once again, there are a lot of easy steps involved beyond the scope of this video, so refer to the Flutter documentation or the full Flutter course. Once you create the actual signed APK, you'll need to create at least an alpha release for your app, and that will allow you to test the Google Play Billing API locally on your device. The Google Billing API simply won't work if you don't have a release created for your app. And you'll also want to add your email address as a tester on that track. From there, we'll go to the Store Presence tab, then to In-App Products, and then go to Manage Products. Now on Google Play, you don't actually select a distinction between consumable and non-consumable. Instead, you handle that directly in the app. And we'll see how that works in the source code in just a minute. For now, we'll go ahead and create a new product with the same product ID that we used on iOS. Now make sure to set your product to active, and then everything else should be pretty self-explanatory. Now that we have the initial setup out of the way, we can start developing our Flutter app. Now I want to start by saying that the code I'm about to show you focuses on the API of the in-app purchases plugin. I want to keep the implementation details as unopinionated as possible, so I'm only using the tools that are built into Flutter, but this is a type of feature that could benefit from things like Provider, Block, or Firebase to manage the state of your purchases across multiple devices and screens. But I'll leave those decisions up to you. I just want to show you how to build a minimum viable product using nothing but a stateful widget. The first thing we'll do is add the plugin to our PubSpec YAML. Then we'll go ahead and import it in our Dart file along with IO so we can do platform checking. I'm calling this the market screen, and let's start by looking at the different properties or state available on this widget. First, we'll make a reference to the in-app purchase connection instance, which gives us access to all of the API methods in the plugin. That'll just keep our code nice and concise. The first part of the initialization process is to check if the API is actually available on this device. Then we'll set up a list that keeps the product details that we query from the Google Play Store or the Apple App Store, and then also a set of purchase details that gives us the user's past purchases. Then we'll also set up a subscription that listens to a stream of updates to the purchase details. So this stream will emit a new value when the user buys a product in the app or if they buy a product from a different client. And lastly, I have a placeholder for credits, which is just used to represent the consumable product in this demo. Now moving on to the lifecycle hooks, during init state, we're going to fetch the products and purchases from the corresponding marketplace. And that stuff is all asynchronous, so we'll move it into its own method. And we also have a stream on this widget, so we'll want to make sure to cancel it. Now the next thing we'll look at is the actual UI itself, which is very simple in this case. We have a scaffold with an app bar that will either display open for business or not available, depending on whether or not the in-app purchases API is available. From there, we'll loop over the products that we fetch from the marketplace. And then for each product, we'll need to determine if the user has a past purchase for it. If they have purchased a product, then we'll create some custom logic to allow them to consume it. Otherwise, we'll just go ahead and display a button that allows them to make a new purchase. This is just a bare minimum UI example, so you'll definitely want to customize it to fit within your own app. Now, the next major hurdle that we'll tackle is initializing all of the data in this widget. We'll do that with an async method called initialize that we call during the init state lifecycle hook. First, we'll check to see if the API is available. And then if so, we'll go ahead and retrieve the products and the user's past purchases. And I've moved that logic into individual private methods just so we get a clear picture of all the steps involved. And I'm sure someone will call me out on this, so instead of awaiting products and then awaiting purchases, you can do it concurrently by using future wait and add both of them together in a list. And that will run them concurrently for better performance. Now, just because you have retrieved a purchase does not necessarily mean that it's valid. So we'll also need to implement some business logic to verify a purchase. And then throughout the lifecycle of the app, the user will hopefully purchase additional products, so we'll want to set up a subscription to the purchase updated stream. This stream will emit a list of newly created purchase details. So when the stream emits a new value, we can take those new purchases and then append them to the existing list on this widget. What you don't want to do is override the existing list because the stream only emits new purchases. So that's just something to keep in mind. So now let's look at the implementation details for this data retrieval. First, we get products, which is no different than making an API call or reading from a Firestore document. We just create a set of the product IDs that we want to retrieve from either the App Store or the Google Play Store. And then we run in-app purchases, query product details. That's going to give us a response, and then we can check that response for errors or to see if any of the product IDs are missing. But for the sake of simplicity, we'll call setState and set the products equal to the response product details. So that gives us our products for sale. Now we need to get the user's past purchases. This is a very similar process, but instead we call query past purchases. But there's one major caveat, and this method does not return consumed products. Because a consumed product can be purchased multiple times, it's not going to be returned by this method. That means you need to save the state of a consumed product in your database. That's the only way the user will be able to retrieve it after this widget has been destroyed. So getting past purchases from the actual marketplace itself is really only relevant for non-consumable products. But one other caveat that you should know about is if you retrieve past purchases, you'll also want to mark them as complete on iOS. Now, if you do have a consumable product, it will be 100% your own business logic to retrieve it. If this were my app, I would be using Firebase, so I would most likely retrieve it from the Firestore database. In any case, the final step here is to call setState and set the purchases list on this widget. Now, the next thing we need to do is figure out if a user has purchased a specific product. In this case, I'm just going to create a helper method that takes a product ID as its argument, and then it loops through the purchases list to see if we have any matching IDs. If we have a match, then we'll go ahead and return the purchase details, otherwise we'll return null. Now the next method is also going to be 100% your own business logic that will take a purchase and then actually deliver it in the app itself. In this demo, we only have a single product, so we're going to see if that user has purchased the product, and we'll also go ahead and make sure that that purchase is valid. The status can also be error or pending, so we wouldn't want to deliver the credits or the gems to the app if the user hasn't fully paid. You'll want to verify purchases both when the app is initialized and then also when a new purchase is emitted through that purchase updated stream. And you may even want to do that server side. So at this point, we have all of the necessary data loaded into our widget, and now we need to give the user a way to purchase a product as well as consume a product. Inside of our products loop, we'll have access to individual product details, which we can then pass to this byProduct method to create a purchase param. That will send the necessary data over to the corresponding marketplace. And then because Android doesn't make the distinction between consumable and non-consumable, you need to do that when you purchase the product. So for one-time purchases, you'll use buy non-consumable. But in our case, we want the user to buy this multiple times, so we'll say buy consumable. Now by default, it will be marked as consumed automatically, which means it's up to your own business logic to control the state of that purchase. However, I would like to point out that you can set auto consume to false, which only applies to Android, and that will prevent the user from purchasing that product again until you actually mark it as consumed. And we can actually demonstrate how that works with our next method here called spend credits. It takes the purchase details as its argument, and then it will decrement the credits on this widget every time the user taps a button. When the user runs out of credits or when they equal 0, we'll go ahead and tell the Google Play Store that that purchase has been consumed. And that will allow the user to purchase another instance of this product. Otherwise, they'll get an error that they already own this product. And that's all there is to it. We now have all the pieces in place to sell our users an infinite number of useless gems, and we just need to refine our dopamine hits and compulsion loops to start making millions of dollars per day. If this video helped you, please like and subscribe, and consider becoming a pro member on Fireship.io to get access to the full Flutter course and a bunch of other exclusive content. Thanks for watching, and I will talk to you soon.